Welcome to part 2 of this week's lecture. We are going to continue with method polymorphism. Basically, based on definition, method calls in Java are polymorphic. The same method call may at different times invoke different methods, depending on the dynamic type of variable used to make the call. So what we have just talked about in previous section is basically form of polymorphism. And we talked about polymorphic method dispatch, basically. So that if you remember that a polymorphic variable is the one that can store object of every type of object in Java. Java method calls are polymorphic, as we said, because they can invoke different types of methods at different times. For instance, that the post.display could invoke the message post display method at one time and then the photo post display method at another time. Depends on the dynamic type of post variable. Another thing that we are going to look at is instances of operator. Basically, one of the consequences of the introduction of inheritance into the network project that we talk about has been that the newsfeed class knows only about the post object and can distinguish between the message post and as well as photo post. So this basically has allowed all type of posts to be stored in a single list. So basically, the instance of operator is being used to determine the dynamic type, and it will recover any lost type of information. Usually the precedes assignment with a cast to the dynamic type. So let's look at an example here. The instance of operator tests whether a given object is directly or indirectly an instance of a given object. For example, object instance of my class returns true if the dynamic type of object is my class or any subclass of my class. The left operand is always an object reference and the right operand is always the name of the class. So for example, post instant of message post returns true if post is a message to post as opposed to a photo post, for instance. The use of instant of operator is also followed by a cast of object reference to identify type. For instance, in here, as you can see, here are some code to identify all of the message posts in a list of posts and to store them into the separate list. So let's look at the object class method. Methods in object are basically inherited by all the classes. The toString method is commonly overwritten. And the purpose of the toString method is to create a single representation of an object. This is useful when any object that are ever to be textually represented in the user interface, but also it can help for all other objects that they can easily be printed out for bugging purposes, for instance. So we write public string and then toString method. Returns a string representation to that object. So let's look at this example, this code here. So we write the toString method for post and message post in here. So in here, basically, we can define the post display method in terms of a call to its toString method. In this case, the toString method would not print out the detail, but it would just create a string with a text. If we look at page 403 on our book, The other thing is overriding to a string. Explicit print method can often be omitted from the class. So we can write system.out.println post to a string method. Calls to println with just an object automatically result into to a string being called. And we can write system.out.println post, which the post can be is the variable which can be dynamic or static. So it means it can print either the message post or the photo post in this case. String builder, we consider using a string builder as another alternative to concatenation. And that's what we are actually using. Before we get to object equality, let's look at some of the detailed explanation of the single println statement inside the loop. So let's go back to this, and we want to actually look at, I don't think I have it here. That's again on page 404. So you can look at the println statement in the for loop. I don't have it here, but if you look at page 404 in your book, you can see that there is on code 11.4, there's a new version of newsfeed show method. So for each for loop, it iterates through all the posts and places it with a variable with a static type of post. The dynamic type is either going to be either, as we said, message post or the photo post. So because this object is being printed out to system.out, it's not a string and it's a to-a-string method is going to be invoking that. Invoking this method is valid only because the class post, which we said is a static type, has a to-a-string method. As we said, it will basically check whether it's done with a static type. This call would not be allowed if class post had no to-a-string method. However, to-a-string method in class object guarantees that the method is always available for that class. And the output appears properly with all the details because each possible dynamic post, as we said, the dynamic post could be either message post or photo post, overrides the to-a-string method and the dynamic method lookup, making sure that the redefined method is being executed. So basically, another thing that we can say about the to-a-string method is very useful for debugging purposes. So we have talked about once about the equality in chapter 5. We will discuss more in this chapter as well. So basically, it's always very important to determine whether two objects are the same. The object class defines two types of methods, equals and hash code. And we always have to be careful when we are going to use some phrases such as the same. Is because it can mean two different things when we are talking about the object. Sometimes we want to know whether two different variables are referring to the same object. That's what exactly happens when an object variable is passed as a parameter to a method. So we actually have reference equality and content equality. So when a reference equality is tested for using the equal operators, so that for example, variable 1 equals to variable 2 are referring to the same object. If variable 1 is true, the result, it could be resulted in a Boolean, true or false. So if both variable variable 1 and variable 2 are referring to the same object, or are both null, it will be true, and it will be false if they are referring to anything else. Reference equality normally doesn't take anything about the content of the object we are referring to. Basically just whether there is one object referred to by two different variables or two distinct objects. That's why we want to define content equality, that it can be distinct from reference equality. A test for content equality normally asks whether two objects are the same internally. That's basically it's testing the internal state of two objects, whether they are the same. So we are rejecting the reference equality for a string comparison. That doesn't work for string comparisons. What content equality between two particular objects means is something that is defined by that object class. So we are actually using the equal method. So we can make use of this equal method between the strings. So we take the same approach, and we're gonna look at this example, which is actually trying to compare the student name, the IDs, and the credit. So the first test is just an efficiency improvement if the object has been passed a reference to itself to compare against, when we know that content equality must be true. So that's the first test, that you're going to look at the reference equality. The second test, if it's not the same type, and if it is the same type. So if the second test, you are going to compare the two students. If not, then we decide that the two objects cannot be equal. And then finally, we make use of the fact that private elements of an object are directly accessible to the instances of the same class. So we use content equality test rather than reference equality test here on the object fields name and ID. So sometimes it's not always necessary to compare field by field in the two objects in order to make sure that they are equal. For instance, if we know for certain that every student is assigned unique ID, then we don't need to test the name and credits field as well. So we can just return the ID equals other ID. Whenever the equal method is overridden, the hash code method should also be overridden. The hash code method is the one that's used by data structure, such as hash method and hash set, to provide efficient placement and lookup of object in those collections. So it is important link between the equal and hash code methods, in that objects that are the same determined by a call to equals must return identical values from the hash code. Interested, you can look at Joshua's blog Effective Java and the techniques that we have used there to actually use the hash codes. So in this example here, you can see a hash code method that uses the value of integer field count and a string field that's called name to calculate the code. So the hash code method count, and then the field, a string field called name, in order to be able to calculate that. The next concept, which is very important, is the protected class. Before I go and talk to you about the protected, I just want to review about the access modifier. Basically, we can have public, private, default, and protected. So we can have these access modifier for classes, variables, and methods. I just want you guys to remember, you can have these access modifier for classes, for variables, and methods. So let's look at the public class. So for public class is basically it's visible to everything, to everybody, to the world basically. So public class is basically visible to the entire world. So we can use public with both classes and methods. So both classes and method, they can use the modifier public. So it depends how we want to use it, but we can use the modifier public only for classes and methods. For private, we only use it on variable, and we can say visible to that class only, and it's the most restrictive one. And most variable basically is using it as a private. And for protected, we can use it for classes. We can use it for function. We can use it for methods as well as variable. So it's visible to the package and all the subclasses. So in terms of inheritance, we use protected a lot. So basically it's visible to the package and all the subclasses. So it's more restricted than public, but it's less restricted than private. So that's what we want to use it. So as we said, basically methods can use all of these access modifier. Method can use private, can use public, can use default, and can use protected. And so basically method can use all of them. And for private, most developers, they use the variable as private. And for protected is basically visible to the package and all the subclasses. So that's how it would work. And I have all of the access modifier here and a definition for you guys. As well as here, you can see in terms of the visibility, we have both of these: public, protected, default, and private. And these are very important. These would be actually in your exam, your final exam, because we need to understand why we use public, why we use protected, why we use private. So for protected, method of the same class, it will be class or member can be referenced by method of the same class, method of subclasses, and method of classes in the same package. So private access in the superclass may be too restrictive for a subclass, so the closer inheritance relationship is supported by protected access. So it's between the private and public, so we can use this protected access. Protected access, as we said, is more restricted than public access, and we still recommend keeping the fields private. Most of the developers, they are creating the variables or the fields as private. So this is again another picture in terms of access level. Again, the access level are very important, and it will come in your exam. So again, public is open to the world, is visible by everyone, and private, it's actually visible to the package and all the subclasses. So in terms of inherited, you can see this class, superclass, and the subclasses. Private, they can only see itself. Basically, that's the private. Visible to the class only. So only visible to this class. And it's the most restrictive of all the access levels. So protected modifier allow a child class to reference a variable or method directly to the child class. It provides more encapsulation than public visibility, but it's not as tightly encapsulated as private visibility. A protected variable is visible to any class in the same package as the parent class, as we saw in the previous diagram. Okay, let's do the final review. The declare type of variable is its static type. We said compilers, they check for static type. The type of an object is its dynamic type. Dynamic type are used at actually when we do the compiling and running at the runtime. Methods may be overridden in a subclass, and methods lookup starts with the dynamic types. And also we said we talked about access level control, protected access, support inheritance. That means that is visible to the package and all the subclasses. I hope you have enjoyed this week's lecture. Please make sure that you read this chapter. It's very important to understand this chapter and the previous chapter. Inheritance is a very important part of object-oriented programming. And also access level. You need to know where you use private, protected, and public. And that is also very important and will come on your final exam. Thank you. Have a good day.